Good morning, good afternoon. I just turned on my camera for just a couple of minutes to introduce myself and the topic of today. So today's topic is FastAct's role, as you see it on the slide, in mitigating electric vehicle battery fire risks. But we will not be focusing on the fire risks. We will focus on the toxic gas issue that arises when you have EV fires. And as Letitia already said, we also have Kyle Knappenberger on this call. He's the technical director of FastAct. So should we move into very technical details about FastAct, Kyle will happily jump in and
Yes,
answer
thank you,
all
Dieter.
of your questions. Yeah. Okay. So I turn off my camera for now, and here we go. That's me. I'm Austrian. My name is Dieter, Dieter. So, I have been working with Timolon for quite a number of years now in business development and as their CBRN subject matter expert. My initial background is actually military, but I also have a strong background in firefighting as well. So now, what's the content of today's webinar is, of course, there are certain key messages that I want to get across, and I'll come to that in a second. We talk about EV fires and especially the angle from which we will approach that kind of problem, the toxic gases, FastAct, of course, then some emergency response and workplace safety considerations, and at the end, conclusions and questions. Of course, we have about 1 hour, so we can only tackle certain issues and aspects of that problem. Should you have detailed questions after the webinar, feel free to reach out to us and we will get back to you in detail should we not have enough time during that webinar to answer all of your questions. Now, the objective of today is how can FastAct empower, as it says, first responders, facility managers, health and safety employees, even private people that have electric vehicles to effectively mitigate chemical vapor risks and ensure workplace safety. So our focus is really on the chemical vapors and the hazards and risks that come with it. And why we strongly think and we believe that FastAct offers a decisive defense against chemical vapor threats. So this is what we're trying to cover in the next 60 minutes. Yeah. So the key message is here because when we look at EV fires, electric vehicles, the fires, and the lithium ion batteries, we only talk about fire. So usually when you read reports, they all focus on the fire issue. But there is another one, a very significant, and that's the toxic vapors and gases. So I'm not talking about the smoke here. We are really talking about the generation of toxic vapors and gases during these kind of fires, even beforehand already. And I will show you some examples, videos on that as well. And here already you see this kind of smoke thing on that picture. Those are actually toxic gases. So I will come to that in a second. So the problem is that unlike the ICEs, those internal combustion engine cars that everybody knows, gasoline, diesel, whatever, electric vehicles and hybrid cars, they are powered by batteries. And those batteries are lithium ion batteries. And of course, they have specific properties. And they pose, because they have these particular properties, a certain set of challenges and risks. And one of the biggest one is this so-called thermal runaway. I will cover it a bit. That means a rapid increase in temperature within the battery. That leads to fires. As I said, the focus is mostly when you talk about EV vehicles is on fire. But we also have a problem that toxic gases are produced. And the main one is hydrogen fluoride. And it poses additional issues and it requires specific protective clothing even, and that is, you know, when you read all the reports, when you talk to first responders, that's what they all say. So, but as I said, the focus is always on fire, but this presentation now is not on the fire issue, it's on the gas issue. So we think a bit outside the box of the classical firefighting when it comes to those electric vehicles and problems, because we will focus on these toxic gases, yeah, that are produced. So, and when you go through, and some of the stuff that I have here, you also find in the last slide that as references, the release of flammable and toxic gases. And this, for instance, comes from a statement from the NFCC, the National Fire Chiefs Council in the UK. Others talk about the potential toxicity, and of course, especially in confined spaces and underground car parks. So why am I mentioning that here right at the beginning? Well, usually, you know, especially people that own EV cars, they have a garage, they park it somewhere indoors, and when you have a release of toxic gases, that even increases the problem that you have, because the concentration levels indoors are always much, much higher compared to incidents that happen outdoors. So people that park their vehicles in garages, that work on these EVs, electric vehicles, in garages, they have a very specific set of issues and problems. And it's not only, as I said, the fire, it's also the gas. And here we think we have a solution for that, which are our fast-act pressurized cylinders, and they come in various sizes. This is just a picture, a representative picture of the four kinds that we have: 400 grams up to 4 kilos of fast-act powders. I mean, pressurized cylinders with powder. Of course, this can also be changed depending on the customer's needs. So there is a problem, as I said, the toxic gases, and we strongly believe we have a solution to that, and that's the pressurized cylinder. So there are quite some similarities when it comes to those fires or incidents with electric vehicles and those internal combustion engines, or the classical vehicles. There are similarities. So it's the smoke, the toxic smoke that you have that comes off from both when something is burning, they're quite similar. And they're also very, very unhealthy. They contain lots of dangerous chemicals. The temperature is similar, yeah. So the heat release rates, they're about the same, 1200 versus 1000 degrees Celsius. So there are some similarities. But then there are also very, very distinct differences. And one, and you will hear it now a lot during my presentation, are those toxic flammable gases that get produced at a very early stage, even before you have already the fire. And the fire in an electric vehicle is also different. Here you have jet-like flames, usually coming from down below. Why? Because that's where the batteries are. And the incident duration is also of significant difference. With electric vehicles, it can take hours. They can reignite, versus the classical vehicles. When they burn, incident duration can be a couple of minutes, can be 30 minutes. It depends on the firefighters. Now, of course, as I already mentioned before, with those electric vehicles, you have toxic and flammable vapors. You have a vapor cloud explosion. And also this I will show you, because some of these gases that get produced, they can explode. Yeah. So, and of course, also at the end, there is the risk of chemical exposure to certain components also of the battery. Yeah. So now, when you look at the phases of such a fire, so before even the first flames appear, gases are already coming out. They look like smoke, but they're actually toxic gases, okay? And they're already coming out before you see the flames. So you have here 6 phases, and at least in 4 of those, you need something also to fight the toxic gases, not only the fire when you look at the phase 3, 4, 4, 5, and then at the end also 6. But those that are circled is the ones that we are targeting with FastAct, our pressurized cylinders, because here you have the emission of those toxic gases during incidents with those electric vehicles. Now, as I mentioned at the beginning, what causes the issue is the so-called thermal runaway. I'm not going to go into each and every point of this, but you see that at some point, step number 3, gases form, and the cells are heating up, phase 4, 5, and 6, and then you have the fire. But already at a very early stage, you have those highly toxic and flammable gases that get produced. Yeah, and when you look through a number of reports, you always find the mentioning of toxic gases, but then when it comes to the response, they're nowhere really there. The focus always lies on fire. And that's where, again, we are coming in with FastAct, with the powder, to fight these toxic gases. Now, this is just a short video on this thermal runaway, so you see how this actually develops. It's a very short video, and you see how this functions, the whole process. Yeah. So unfortunately, also, if you use water, you need lots of water. Depending on the literature, the reports that you look at, we're talking tens of thousands of liters of water, thousands and sometimes tens of thousands of liters of water, even in gallons. So it's a lot of water that you actually need, but still you have the risk of reignition. Okay. So, of course, there are different kinds of lithium-ion batteries. Some are extremely well regulated, that are on electric vehicles, buses, trucks, but then you have all those light electric vehicles where the lithium-ion batteries are not so well regulated. The standards are different, and they also pose a significant risk. And as they are lithium-ion batteries, they also produce this toxic gas, and we will see that in a second when I show you some videos, some short videos. So, as I already said, why is there such a difference between the different kinds of batteries? So in the vehicles, you have these very high quality lithium-ion batteries. Why? Also because, of course, you want to be able to drive a certain mileage. And you have a very, very sophisticated battery management system, BMS. You have sometimes a poor battery management system in the other vehicles, those light electric vehicles. And much fewer, less safety considerations. So, and the thing is also with those light electric vehicles, a lot of times they're just stored and really charged indoors. When you look at these scooters, some people even bring it to their living room to charge it. And I'll show you in a second what can actually happen if something goes sour with these kind of even small batteries. So electric buses is also something that is coming more and more. So here just some examples. What happens when electric buses, when the battery goes into this thermal runaway. So you see here a massive fire. But again, as you see here now, when you see this, I stop for 1 second. Before it actually ignites, you see all the gases. Yeah. So it's not only the fire, there are a lot of toxic gases, and the toxic gases, unfortunately, are always produced at a very early stage. So what does that mean? Even for people that work with electric vehicles, buses, and things like that, you would need something to be able to fight those toxic gases right away before even the first responders come. Here you see it again, this cloud, and then of course it ignites because some of the gases produced, they're also, unfortunately, they can ignite and lead to explosions. Now here, something goes wrong when charging the vehicle. And here again, you see all these, it looks like smoke, but those are all toxic gases. Yeah. So at a very early stage, they get produced and you have a lot of it. Yeah. So even the production of these gases doesn't stop when you already see the fire. And imagine now that when you have one of these cars parked somewhere indoors, the entire indoor space will be filled with these toxic gases. Also, what is of interest and what is to know that most of these toxic gases, they're actually lighter than air. So they go up, they rise, especially of interest if it's parked in your garage at home, and then those gases get generated, so they move up, they move upwards. So bear that in mind. Now we talk about light electric vehicles. Yeah, and just look at this video, and you see what happens with these electric scooters because people go with them everywhere. And just wait a second, and then you see what actually is going to happen here. Number 2 comes in the elevator. The elevator door closes, and number 2 is already realizing that there's something wrong. And here you go. And now you see how quickly these toxic gases are produced. And they're highly, highly toxic. Luckily enough, they managed to make it out of the elevator. But you see here you have extremely high concentration of specific toxic gases, and which toxic gases we will look at in a second. So not only do you need something to extinguish the fire, you also need something, especially in buildings, indoors, to fight the toxic gases. And this is a bit of a stepchild in this entire EV industry, the aspect of toxic gases. So you look at the fire suppression, and as I said, you find really tons of data on fire suppression, even though not too many SOPs are published. Different countries deal with it differently. So here you see on the right-hand side, brandweer. This is actually from the Netherlands. So cool burn and submerge. So that's what they do. Sometimes it's cool burn, they cover. They use tons of water, but nobody does anything against these toxic gases. You don't see it anywhere because also the first responders are not equipped. People that own electric vehicles, they're not equipped to do anything against toxic gases. Some of them might have fire extinguishers specifically designed, manufactured for the purpose of fighting fires of electric vehicles, but for sure they have nothing against the toxic gases. So here, and I think here I left the sound on purpose. Also, you have those toxic gases, and as I said, some of them are quite flammable, and they have, when they reach the explosive limit, meaning they have a certain concentration, especially in confined spaces, then this, sorry guys, then this is going to happen. So you see the thing just blows up, and at times this can happen at a very early stage. As I already said, the gases are produced at a very early stage. Also here I left the sound on. I found this on a website that I have referenced at the end from some training videos, so I cut this out just to see what actually happens here.
Vehicle that's smoking. It's a vehicle in a parking lot. At 12:10, they arrive. 12:16, they've got their hand lines stretched, they break out a window, they start spraying water inside the vehicle. But at this point in time, the vehicle's completely full of smoke. They can't see anything inside. They're not really sure what they're putting water on. At 12:19, they break out a second window. 1 minute later, it launches that removable roof up into the air.
So you see what happens with these toxic gases. So it's not only are they toxic, it can also blow up. So this is another issue that you have here. Is another one, another example.
After this vehicle is open, and you'll see as the conditions get just right, it's going to pop. And there it goes. All that gas is burned away. But had that hatch been closed, had that gas been confined to the interior compartment of that vehicle, it could have been a very large, very loud explosion.
So you see here, it's not only the fire hazard that you have these toxic gases, and you see here those clouds that come off that vehicle, those are all those toxic gases. It's not smoke from burning like what we are used to. As I said before, the similarities between the two vehicles, the internal combustion engine and the electric vehicle. Yes, they can also burn, certain components of the vehicles burn. But here, initially, we have only the battery, and the battery produces all these toxic gases. Yeah, and these toxic gases, they can also not only affect you through their toxicity, but also if they have reached a certain concentration in air, they might blow up. And because you have the battery on fire, so this is what then causes the explosion. Yeah. So now we talked about these kind of gases, and there are a number of them that gets produced: hydrogen cyanide, hydrogen chloride, hydrogen fluoride, and now we look at some to understand a bit better the gas hazard. Yeah. So first of all, I wanted to show you that it's not only a fire hazard. There's also a significant gas hazard that you have when you have an issue with electric vehicles. Vehicles, not only cars or big vehicles like buses, but also like scooters and these kind of things that some people even have home. So now we look at some of these gases. So I really call it the underestimated threat during EV fires, because the focus for now is on fire and not really on these gases. And I'm not going to read the text out to you, but there are a number of toxic gases that get produced, and predominantly it's hydrogen fluoride, and some of them are extremely flammable, even like carbon monoxide, and then they can blow up. And here I just quoted one of these firefighters, and he said, and he called it an array of nasty toxic gases. So again, not only fire, but also lots of gases. So now some research took place, and there is really not too much out there as of yet when it comes to all these toxic gases. You find much more about fires. Toxic gases, there are really limited data out there. And some of them, as this is all new, are of course very, very recent. Yeah. And you also see it here in the references. So this is the setup. And then they caused EV fire, and then they were collecting all the gases, and then they were looking at, okay, which kind of gases do we actually produce with various types of detection instruments. So with one of them that they used, the FTIR, they found a number of gases. And as I said before, predominantly is hydrogen fluoride and also a number of others. And FastAct works against many, many of them. We have tons of test reports. And as I mentioned before, we also have Kyle, our technical director, on the call. So, and I picked out one, which is HF, which is the predominant one. And we look a bit more into this. So there are certain components in the lithium batteries that then when you have a fire, that causes this specific gas. Yeah. And those HF emissions are quite dangerous. A number of first responders have noted that already. And it also depends, of course, on the kilowatt hours of the battery. There is a strong link also on the size, between the size of the battery and the HF emissions, meaning the concentrations that you will face. So again, you find quite some data on this HF gas. You have those acute exposure level guidelines, and I assume a number of you are familiar with them. So that's mainly used by emergency planners and responders worldwide, actually, as a guidance in dealing with either rare or usual accidents and releases of chemicals in the air. And here we have hydrogen fluoride, and I just looked at the concentration levels out of curiosity. When you look at the various levels, 1, 2, and 3, and of course 1 being the least dangerous one up to very dangerous levels. So you see here the ppms and the exposure time. So if you have a concentration of 1 ppm, how long can you stay? Yeah. That's when you see here with those concentration levels, we can actually link it. We can link it to HF. So and what was of interest here is because when you look at these spikes, the HF concentration in parts per million ppm over time. Now you might say, well, but there is, the first 60, 80 minutes, it was very low. It was very low because in the initial phase, this shaded phase here that you see, they used sprinklers. So they used a lot of water, yeah. So to extinguish the fire, but you still had 2, 3, 4 ppm. But that implies that first response is already taking place. If first response is not taking place, then you have extremely high levels of HF. And that you see here because the thing reignited, and then we go beyond the limit of quantification of the instrument. So we really have extremely high ppm values. And also what this clearly shows is that without an immediate first response with lots of water, you will have quite high concentrations in the air. Those trials were done with the 50 kilowatt per hour battery. When you look at electric vehicles now, they usually have, I'm not the big expert here, but they have 40, 50, 100 kilowatt hours batteries, so quite strong. So here also, this is a linear, but again, this is logarithmic, okay? So you see here already when you have the electric liner sheet, so this is 10 kilowatt per hour. So here then you look at the amount that is released and the total quantity. And also this tells you already that when you have an incident with an electric vehicle indoors, you really have a problem. You have a much bigger problem in terms of gas, of course, than outdoors. But that's always with toxic chemicals, with concentration levels. That's what you have. Outdoors, it's always a factor 10 or 100 times lower than indoors. But what does that mean? People park their electric vehicles in garages. You have huge parkings which have those wall boxes where you can charge electric vehicles. So if something goes sour, then you have that indoors, and that means you have definitely very high concentrations of these toxic gases. First responders, usually they are protected because they come in with their SCBA. However, HF depends also on which kind of protection they wear in terms of protective suits. They might also have a problem through skin. So, but for those people not being protected, there is an issue, and you need to fight those gases as soon as you can. So as soon as you realize there is a problem, you need to start fighting these gases. Yeah. And this is again where we come in. Yeah. And the fast act pressurized cylinders, they provide a much needed, and I was trying to underline that with the last few slides, and a simple response tool for harmful gases and airborne chemicals. This is basically, it's used like a fire extinguisher. It's a pressurized cylinder. It has a special powder in it. Fast act is not a fire extinguishing powder, but it is there to neutralize harmful gases. Yeah. And example, HF. And if you have more questions on that, Kyle is happy to jump in. This is very well documented. So lots of trials and tests have been done with HF. I myself, I used Fast Act and the Fast Act powder to neutralize very toxic vapors in air, for instance, from nerve agents. And that worked. So immediately, so there was a very quick reaction. So with HF, we have that. Now, Fast Act, just a bit going into the history of Fast Act. Initially, Fast Act was developed for the chemical weapons stockpile program in the US. Now, with this chemical weapons stockpile program in the US, also a lot of civilians have been employed and working for that program, not only the production itself, but later on the destruction. By the way, the US, now it's almost a year ago, they destroyed their last piece of chemical weapon last year in July. So that's where Fast Act comes from. And it has a very high surface area, and it's a dry powder decontamination solution. Yeah. So for various surfaces, even now for skin with Fast Act, we have the approval that you can use some of the pieces of equipment, the Fast Act mitts and the wipes on skin. So this clearly shows that this Fast Act powder is not toxic. Yeah. So and then later on, one went more and more into the area of toxic industrial chemicals. So Fast Act works extremely well against specific toxic industrial chemicals in vapor and in liquid form. And that's the interesting part. So liquid form, you have a number of products that work against the liquid forms, but not the vapor. So, and that's what Fast Act does. And it comes in and neutralizes vapors, dangerous vapors in air. There's a lot of data on the safety of Fast Act, and we had to produce it also recently for this CE process. A lot of additional testing had to be done in the area of safety. So eyes, lungs, skin, everything else. So that was done. So if you have any kind of question when it comes to safety, we're happy to provide the reports. Just send us an email and we can actually flood you with reports. Now, unique properties, the chemical reactivity. As I said, it has a very large surface area. It consists of two main components, titanium dioxide, magnesium oxide. It works extremely well. And there is just a long list of patents on this kind of product as well. I'm not going to read that out to you. It's just that you know that there are a lot of patents on that product as well. It decontaminates, contains, and neutralizes. Of course, what is of interest, especially for the gases, is the containing part. So it absorbs a number of gases, and I come to that in a second. And it neutralizes also quite some gases, especially all the stuff that is has to do with acids. It works extremely well. It works extremely well against certain chemical warfare agents and a number of other chemicals that you see here, chlorine and also others. And decontamination here is not so much of interest in this kind of scenario. For us, it's the neutralization of toxic gases and the containment of especially some of these explosive gases. So the neutralization with pressurized cylinders. So here is just an emergency operation. Basically, now it's used on a first responder because it can also be used for emergency decontamination, but we are talking emergency neutralization. So we blow it in the air to neutralize these very toxic gases that are so harmful and that get produced during an EV fire incident. Vapor hazard, ticks, toxic industrial chemicals, and chemical warfare agents. So those toxic industrial chemicals, there's a lot of testing out there also on Fast Act, its efficiency, how it works, what it does, a long list of chemical formulations as well. So if some of you are interested in that, then of course we can always provide you with those kind of data. As I said, lots of different kind of testings. For here, you have a 28 cubic meter room, a 95% reduction of some of the gases. Here you have the amount, what is needed, 1 kilo, the ppm, and the efficiency, as I said, has been tested. Yeah. So again, for instance, if it's just my own personal opinion, if I have an electric vehicle, I have a garage, not only do I have something against the fire problem, but I also have something against the gas issue. Because as you have clearly seen, we do not only have the fire problem, we have a very, very strong gas issue with those EVs. Now, this is what this looks like. This is Kyle when he was a bit younger. This is how you release it, like a pressurized cylinder that you use for firefighting. Very easy. And to that extent, I also have a short video out here. So that's myself just using it with a different kind of protective equipment. But you see here, it's like I just blow it in a small shed for some field trials that we were doing, because we were using some detection equipment before and after, again, to see if it can neutralize, knock down these kind of gases that were in the shed, and it worked extremely well. So as I mentioned before, we also have this explosive risk. And when you go on the Fast Act website, under resources, you find a search engine. You can type in the type of chemical that you're interested in, and then it will show you what Fast Act does or cannot do. And you have adsorption, decomposition, for instance, for hydrogen cyanide, the reaction rates, and these kind of things. So just to show you that some of the components that get produced are, for instance, also methane. There, of course, they lead to an explosion. So also there, you want to do something against that if you're there early enough before the battery starts, as they call it, running away, this thermal runaway. You can also fight these type of gases. So then hopefully you can avoid also the explosion. Yeah. So now just briefly some emergency response, workplace safety, just some considerations. As I said, it's only 1 hour, but just to give you some ideas of potential applications also of Fast Act. So first responders, I mean, the firefighters here, again, I just quoted a few things, and they always talk about toxic gases, even though here they call them toxins, but they're not toxins because that's something else. But they meant those toxic gases. They present a major risk to other emergency services, police, ambulance officers, bystanders, the broader community. So again, it's a real problem. It's there. It has been recognized. It has been mentioned. We know which kind of gases get generated, but still it hasn't really found its way into the response mechanism, even the stuff that you can do yourself as an EV owner. Yeah, usually many people carry a fire extinguisher in their car. What you should do when you have an electric vehicle, you carry not only a fire extinguisher, but you carry also something that you can fight the gases. Because as we have seen, those gases, sometimes they get generated extremely quickly. So you want to be able to do something even before the fire actually breaks out. Yeah. So toxic gases, again, they talk about an array of deadly toxic gases. And here, this is the United Firefighter Union of Australia. And this is 2023. So all of these quotes are not, that you say, well, it's old stuff, but it's fairly new. Why? Because also now electric vehicles are coming more and more. So we should really think a bit outside the box and say, well, there is not only the fire hazard, we also have the toxic gases. And the thing is also with first responders, and here I took that from Euronews, it says here that developing new methods and guidance on training firefighters are the only way to address fires in electric vehicles. So new methods, and one of the new methods is also to fight toxic gases. So as I said, let's think a bit outside the box. It's not only the fire, it's also the gas. Buses. A lot of times, these buses, they have the battery high up. So, and they have big batteries. And as you have seen before, electric buses are no exception to this problem that we have. And sometimes they also carry lots of people. Imagine at airports now, if you have electric buses full of people, they're waiting to be transported to the plane. The doors are all closed and something happens. You have these gases generated very, very quickly. So in my view, also, all of these electric buses should not only carry something to fight the fire, but definitely to fight the gases, at least until the moment that everybody is out. Yeah. So, as I said, the batteries are usually on the roof. And because you have those low floor requirements for even handicapped people now, all modern buses. So, and that also generates another kind of problem because of the access. So if you come as a firefighter, you have a bus, how do you get quickly on the roof? So that's why you should really, and I'm repeating myself, but that's the purpose of this webinar anyway. You should be equipped to do something against the toxic gases. Here is again a short video. I just let it play. There are tons of videos out there, but this is just what happened in a private home with not even a very cheap electric vehicle.
Thank you. A Centennial couple is out of their house tonight after their vehicle caught fire. The Jaguar I-Pace was charging at the time of that fire, and Fox 31 has learned that thousands of those I-Pace models are under recall. It's because of fire risks in those batteries. Kim Posey shows us the new tool that firefighters are using to handle EV fires.
Most of the fire damage is here in the garage, and it is boarded up, but there is smoke damage throughout the home. Video from South Metro Fire Rescue shows smoke coming from the home on Mobile Street in Centennial.
We woke up and our garage was in flames.
David Frosch and his wife heard the smoke alarm and got out unharmed.
It appears that our Jaguar electric vehicle spontaneously caught fire.
Their 2019 I-Pace EV caught fire while charging, and the
So you see, and that's what I said before, you have your electric vehicle sitting at home in the garage. The garage is closed and something goes sour, and then you have at first the production of toxic gases. Of course, they had smoke alarms, so they managed to get out. We all know about sprinkler systems. Sprinkler systems are filled with water, but they to some extent work with some toxic gases, but maybe, as I said before, let's think outside the box. Sprinkler systems filled with powder to fight toxic gases, because a sprinkler system alone will not be able to extinguish fires of car batteries, electric vehicles, because you need tons of water. So as I said,
Thank you. A Centennial couple.
Toxic gases. Airports. Now, more and more airports are switching towards electric ground support equipment. Some of it is quite outside any kind of regulations, and also there, this is not an electric one, but it's very close to the plane. So what if something happens? You're close to the plane, you have passengers already inside, you have really a lot of toxic gases that get produced. What do you do? So again, just some examples. As I said here, all of these things, when they are battery driven, they're very, very close to aircraft. The shipping industry. So we have some examples here now also of some huge ships that even sunk because they had electric vehicles on board. The thermal runaway happened, and again they say, well, a lot of toxic gases have been produced as well. So and this is when you talk about this incident here, the Felicity Ace. And when you see all that smoke that comes off that thing, so a lot of it is due to those electric vehicles. So you have quite some toxic gases that are coming off that ship. So again, as I said, it's not only fire, sprinkler systems, maybe also with some powder. Yeah. Emergency management considerations, as I said, just to give you some ideas. There are still some gaps in legislation and guidance. The proper risk assessment, usually it's only done for fire. The risk assessment is done for fire, but not really for toxic gases, because nobody has them on the radar. As I already said before, there's a 3-step approach of most responders, but that doesn't involve the toxic gases. So risk assessment, one should really look at. The risk profiles, emergency management practices. So one should start looking at, again, these toxic vapors. And there is limited real-world data on these toxic gases. As I said, there are some data, but still not enough. So, and fire and toxic gas safety equipment should be on board at workplaces, at homes, in cars, whatever, because we're not only talking fire, we're also talking toxic gases. Yeah. So this brings me to the end, actually, of this webinar. It's FASTAC pressurized cylinders. They really provide a much needed and simple response tool for harmful gases in electric vehicles, in fires. As I have hopefully managed now to show you, there is a problem with these toxic gases. For now, nobody really has them on the radar. They all know about it. At least the first responder community talks openly about it. Some even say bystanders, others, the police, ambulance services, they are at risk from the hazard coming from these harmful gases, but nobody is really equipped to do anything about it. These FASTAC cylinders, that they come in different sizes, they are really very, very easy to use. I mean, I use them in all sorts of settings, and sometimes people that just had a 30 seconds brief on it, it's like a pressurized cylinder for firefighting that you have at home. And also, I put a small note now. What we are starting to look at as well is the burn site pollution cleanup. That's also something that we're looking at now. So because of course there is quite some chemical residue at a burn site. So and we are sure that also FASTAC can do something about that as well. But then we're not talking pressurized cylinders. We're more talking the powder component alone. But that's something that we have just started looking at now. So plenty of data out there on toxic gases, how the FASTAC cylinders work against the toxic gases produced by EV fires. And that actually brings me to the end of the webinar. Those are the references, some of which I used. And of course, there is no webinar on some products without at least a little bit of sales contact information. So here are the 2 sales guys, George and Greg. So if you have any kind of also questions, any kind of follow-up, please reach out to those guys. they will then be happy to get back to you, even send you more technical information if you need it. But as I said, this brings me to the end of the webinar. Happy to answer any questions. Also, Kyle is still there, so if you have some questions now, then happy to answer them. Letitia, I cannot see the chat now on this thing, so if there are any questions, maybe you just have to read them out.
Dieter, there's a Leticia. I'll go ahead, and I know there's a question or two there. So, one of the things though I want to kind of point out though is, Dieter, thank you very much for running through that. Did a fantastic job. You saw in those videos and some of those pictures, a lot of people when the first responders or fire is responding to the fire, they are in proper suits and geared up. But some of the things out there though is, by profession, fire response has one of the highest rates of cancer just in general because of toxic gases created on site. And a lot of times people think, well, once the fire's out, the bad situation is over. But really all fires have toxic gases produced and generated during the event. EV batteries just add in some additional ones that are really quite problematic. And our technology in Fast Act in these pressurized cylinders has been used for a number of years for those types of gases in other situations as well. It really is a great solution, though, if you're, in particular, what I'm thinking about those EV charge stations, like airports or in businesses that have, electric vehicles for moving materials in warehouses. You have enclosed environments where if that fire is created, it's going to release a lot of different things, and enclosed areas are some of the more problematic ones for ventilating these types of gases, and having something that can quickly knock it down, releasing 4 kilograms of Fast Act powder into the air, it will dramatically help in those types of situations. We have an electric vehicle charge station in our facility, in one of our facilities here, where I happen to be. And of course, we have all the proper response tools, including, of course, Fast Act located in close proximity to that. It's like Dieter said early on, it really is kind of a unthought of or hidden danger of EV fires and fires in general is what you may be exposed to exposed to after the fact, when you actually think it's over. And a lot of recommendations for EV fire response are often, we'll just let it burn because it takes so much water to do it. Well, then that's generating quite a few gases that obviously need to be addressed, particularly if there's enclosed spaces or areas where ventilation is quite difficult, like that image of the ship. Well, it's outdoors, but there are, that stuff is going to get into places and those people can't escape all the time. A question though was on deployment and quantities. Really, the pressurized cylinders is one of the most rapid ways to do so. And really the larger Fast Act cylinders in these types of situations are going to be able to cover the most volume of space, and having like a 4 kilogram cylinder located in near proximity to those types of situations is what is going to be best.
Hi, we had another question under the Q&A that was, does the proximity of the open flame from the battery fire affect Fast Act or its effectiveness due to high temperatures?
The temperatures that we're going to see with fires, I mean, they get pretty high, but they're not going to overly impact Fast Act at those, 1,000, 1,200 degrees C because of the it's just short exposure for Fast Act and its device. You know, when you're dispensing a Fast Act, you're not going to necessarily be quite at that temperature where it's being dispensed from, but the powder is going to be able to do its thing very quickly before the efficacy would be harmed by those temperatures. It's going to be able to do it pretty quickly. And in a lot of these situations, again, you're, as Dieter kind of mentioned earlier, it's a two-step approach of, you know, let's address the fire and then let's address the gases as well.
Just one quick comment to that as well. Of course, with the Fast Act pressurized cylinder, you're not aiming at the fire. So you're aiming at the gases, the vapors that are coming off. Yeah. So you're aiming at these, let's call them clouds. That's what you're shooting at. And also, what appears first, and this was what I was trying to show you also, is at first you have the gases, because the battery starts venting. At some point it breaks open. So at first you have the gases, and then you have the fire. Sometimes it's almost at the same time. Sometimes there is a specific delay. But what you're shooting at with the Fast Act cylinder is not the fire, because you cannot extinguish the fire with the Fast Act pressurized cylinder, also because of the quantities and everything else. But you're shooting at the clouds, especially in an emergency setting. You want to get out, you want to save people, and you really want to reduce the amount of toxic gas in the air. You want to clear a rescue path or whatever you want to do. So that's what this is actually for. In enclosed spaces, you want to get out. The concentrations will be very fast, very high. So, and that's what I mentioned before. Here we have the pressurized cylinders, but also for other areas, because you have smoke detectors. You might also look at, I call them sprinkler systems because everybody knows what that is, but not filled with water, but with Fast Act powder, because that really knocks down the toxic gases and people can get out. So if you have huge garages, parking garages, you have smoke detectors, you have EV, electric vehicle charging stations. So you might, if something happens in a particular area, you might want to trigger your sprinkler systems with powder. So as I said, let's also think a bit outside the box, because all of the data that I showed you are extremely new. The concerns are very, very new. They're all 2023. So it's not something that is old, and people are already saying we need to look at the response mechanisms that we have. And here we're not talking only first responders. We're talking at owners, as Kai also pointed out now, is owners, transport systems, airports, you name it, because they need to be able to do something before even potentially the first responders arrive on scene.
We have another question. Are the cylinders one-time use?
Kyle, that's you.
Yes, the cylinders are filled with the Fast Act powder and are considered a, you know, once you fire it off, dispense the powder in its entirety. It's not a refillable thing because of the way that the powder flows through there. It wouldn't necessarily seal correctly. So yes, it is a one-time use thing, but really you want to utilize the cylinder all when you do dispense it, because you wouldn't, you know, if you partially discharged it, you wouldn't really have an indication of how much material is left in the cylinder. And another question that came in, do cylinders expire after non-use? Yes, they are generally, you know, customers that purchase the cylinders, they're going to have, it really is no different than a fire extinguisher, typically a 5-year lifetime on the cylinders. If it were to not be used within that 5 years, great, I'm glad you didn't have a fire. But at that point, we could always work with customers on replacement program pricing.